What do you think, Ilan? Should we get going here?
Yeah, I think so. Let's start.
Go.
So my name is Ilan. I'm from TAG. Of course, as you know, I'm the VP of Tech Ops, residing in Tel Aviv. With me is Paul, our Chief Architect from Canada. And today we're going to talk about live production on the cloud. So let's start with,
Let's do that.
What is live production anyways? Paul.
Oh, what is live production? Put up your hand if you've ever been involved in live production. And if you do so, I can probably smell your sweat from here. Live production is the highest stress, highest anxiety environment there is. It's even worse than shooting film because you can do retakes in film. I mean, when you're live on air, there is no going back, right? You have a start time and you have to start the show. It's produced in real time. There is no rewind. You do not fix it in post, right? So live production is very, very important, and it's very, very high stress.
Yeah.
In live production, we work with uncompressed media. Even till today, traditionally, all the way from the analog era, we've used baseband video, baseband audio, because it's the highest quality. It gives us the best production tool to work with, so that if we have to go through generations of processing, we can still maintain quality. It's also the lowest latency, because when you're doing a live production, you want lowest latency for interaction with your studio, with your performers, and so on. And that's led us to analog video and audio, of course, and then SDI, and today's SMPTE 2110. There's also multiple elements involved in a production studio. You could get a video toaster and it's all in one little thingy, but typically studios, especially high-end ones, involve a large amount of equipment from best-of-breed manufacturers such as ourselves, and you put this together into your production system so that you have things like graphics and character generator, replay and slow-mo and special effects and DVE and external sources and on and on and on. It's a complicated system. It's a control room full of people under high stress. They're yelling at each other, not out of anger, just to get the show done. Ready on two, take two, right? Other people are on the intercom. And it's a brick or mortar facility. It's a building or it's a truck. There's racks of gear and there's miles of cable. That's live production. Typically, it's centered on a routing fabric, so you can configure it to some degree. A cross-point SDI switch, or in the case of an IP plant, it's an IP switch. So what we're going to do is examine the evolution of live production and how it can move into the cloud. We'll look at an overview of it and some challenges and opportunities associated with that.
Yeah.
How's that sound, Adi? Ilan?
Yeah, it sounds great. Just from my experience, I worked 10 years for the biggest news company here in Israel. And if there was a news event that didn't go without yelling from the director or the producer, threatening to fire someone after it's done, it wasn't, something was wrong.
I see you've worked in live production.
Yeah, I worked in live production, the meanest one.
I've got my scars.
Yeah. We have a live production, legacy live production example. Paul, you care to say?
Yeah, it's a simple block diagram just to illustrate the pieces for those who maybe aren't familiar with live production. But it involves a whole bunch of sources on the left. I guess I can use my. That's your arrow. Oh, thanks, Ilan. Yeah, so there's a bunch of sources. Elements you use to build your show, and these are ingested into your network. In this example, it's an IP media network, but an SDI system doesn't look a lot differently. The flows remain the same. And then within the system, you have things like replay and slow-mo. You have graphics. You have, of course, the vision mixer, the all-important vision mixer, the operator of whom is yelled at the whole time. And you have all these other sources I mentioned before. And then your entire production in the control room or in the control environment is centered on a multi-view processor today. It used to be a monitor wall full of TV sets. I've actually built those in the past. I'm glad we don't anymore. Yeah. And this is what gives you the visualization and the monitoring of your production. And then these are delivered to different screens for different purposes. Right. So video operations, they need one thing. The people at the back desks doing coordination need other things on their screens. Audio needs different things again. The camera shaders need something very specific, and on and on and on. So that's the purpose of a multi-viewer. So generally, this is the architecture of a production system we're talking about.
Okay, so this is the IP architecture, but for the SDI, it's just replacing the IP with cables, physical cables, miles and miles of them.
Yeah, we're just showing flow here, but this is based on using 2110.
Thank you. Cloud computing. I'll talk a bit about cloud computing and cloud in general. Cloud is basically a place that offers all the services that you need compute-wise and other services, but not on-prem. You have access to these services from anywhere in the world. They are very flexible. They're always the best and edge-cutting services that you can ask for. They're always advancing, they're always adding new services to help you out. A few examples like flexibility, that you can have as many VMs on the cloud as you want. If they turned off, you don't pay for it. You can scale them up or down as you wish. Security layers, many security layers. Just a small example, if you want to set up a security network system on-prem, it will take you weeks. A lot of equipment and a bunch of expert IT guys. In the cloud, a few clicks, many tutorials. You need some knowledge of IT and you have your security set up and ready to go. Many benefits that the cloud itself and the cloud computing presents, and especially now that more video services were added, this is the future, and this is where we want to go regarding OTT video streams. And here, of course, we have a list of a few the major cloud providers. I'm sure everybody has their own favorite ones. Today's topics that we're going to address, basically, we'll try to help you from A to Z to understand how to get your live production migrated to the cloud, or even do a hybrid version of that. Some on-prem, some on cloud. Everything is possible. Everything is okay. We'll start with how to convert your ways to convert your STI streams to IP, how to move the streams to and from the cloud in a safe way, in a secure way. We'll talk about a bit about the cloud regions, the VMs, instances, costs, and some services there. How to pass your video streams through the video components on the cloud itself. The services you'll need to use when you're doing live production on the cloud. And of course, at the end, we'll talk about the advantages of the cloud versus the on-prem regarding to live production.
Sounds good.
Yeah.
Yeah. So, you know, let's assume nobody has any analog streams anymore. But if you do, you're looking to convert those to SDI, probably as a first step. And as you move to IP, you need to get out of your SDI environment into IP. And so SDI, of course, is uncompressed, and it's essentially going to a transmitter in a legacy environment. I mean, SDI was invented in the days of TV broadcasting from the big transmitter on the hill. So SDI was typically delivered to transmitter and or compressed systems such as cable, satellite, one directional point to point. As far as your system goes, got to remember that on-premises bandwidth is free. As soon as you put in a coax to a device, you paid for the bandwidth for that device. This is unlike IP, where your bandwidth is a bucket and you use it up in small pieces as you allocate it to equipment. And in 2110, we get SDI in and out of 2110 using devices called gateways, encapsulators and decapsulators, which convert from SDI, video and audio metadata all in one stream, into individual streams of IP in 2110, audio video metadata, or in the case of SMPTE 2022-6, we take the SDI and we wrap it in IP for transport. But in any event, to get into the cloud, there's no more SDI. We're purely in an IP domain now. So when we talk about IP, the on-premises bandwidth you have in your IP plant isn't free because you bought a big IP switch and a bucket of bandwidth, but it's cheap as compared to SDI because that bandwidth is reusable, it's reallocatable. You use the bandwidth for something right now, and 4 hours from now, you can use that bandwidth for something else, unlike SDI, where one cable goes dark and another one lights up and you paid for them both. Today, cloud IP bandwidth is limited compared to your own building, because in your own building, you can buy anything you want. But that is changing rapidly. With the last mile rates going up from your premises or your home or anywhere into the internet, plus the bandwidths of the backbones continuing to increase in all the cloud providers, we're seeing the bandwidth continue to escalate, and we're now at the point where live production is entirely a possibility. This wasn't the case even just a couple of years ago. When we want to get to and from the cloud, and Ilan will talk more about this, we want to be using mezzanine compression because we're limited on the paths into the cloud. If you want to do remote production and you're at home and you only have a 50 megabit link, then we have to use a compression technique that's appropriate with the link you're using. And then we want to also use forward error correction for resiliency, and we have to have very, very low latency in all cases, because production systems are live, they're meant to be low latency, and now we're going out of our building into a wilder universe. So we have to use techniques to make sure we can keep our latency minimized for live production needs. So on the next slide, Elad.
Thank you, Paul. So basically, what we're saying here at TAG that even today, you can go ahead and do a full production, live production pipeline solely on the cloud itself. Just find a way to stream your events from the studio, from your cameras, or anywhere on the field to the cloud, and everything else, including the distribution to the clients, can be today done on the cloud, right, Paul?
You know, yeah, precisely right. And let me add one more important thing. Mm-hmm. If we're talking, let's say 2110, you can mix and match what pieces are in your premises and what pieces of that are in the cloud. You don't have to move everything, forklift it out of your studio into the cloud. You can move certain elements of your production into the cloud, keep other elements of it in the traditional manner, and migrate them as necessary. This is the beauty of IP now. You don't have to build a room and wire up equipment and commit rack space. You can evolve as you go. And maybe today your character generator's in the studio, and then you buy the web addressable cloud resident one, and you move it out. So hybrid facilities using cloud and on premises with 2110, for example, in IP, is entirely possible in any way you want to formulate. And this is hugely powerful.
Yeah, this is like a huge progress from, let's say, 5 years ago.
Well, imagine you have one studio and a news item pops up and you have to cover it urgently. You can stand up in a second news studio in the cloud in minutes. Yeah,
that fast. In this topic, we'll be talking about how to move your streams to and from the cloud in a safe and error-free way, as much as possible, of course. You know, nothing is perfect. It's still over IP. But you can get next to perfect solutions when doing that. As Paul talked about the last mile bandwidth, you know, it can be limited. You need a secure and fast way to upload your streams to the cloud itself, and there are many options available there. For instance, taking the AWS example, you have the Direct Connect and the CloudFront to do that. The regional and backbone bandwidth that will allow you to move your streams within the cloud and between regions and between different virtual private networks and so on. So the services today fully support you doing your live production deployment on the cloud. As for the packet loss and data errors, of course, TCP is the recommended protocols to use because it will give you the knowledge if the streams got to their destinations in a good manner. The forward error correction will wrap up your stream and open it on the other side, so you get the stream exactly as it left your encoder or any system that provided the stream that the stream originated from. So that's the FEC protocol over TCP. Security. For security, we have a few ways to handle it. For OTT streams, you can use tokens, of course, encryptions that will allow you to somehow wrap the streams that will be accessible only to people that you want them to be accessible to, of course. Mezzanine compression for essences, we use the mezzanine compression because it offers good quality and a lower bit rate. And the lower bit rate will save you bandwidth, but give you for mezzanine compression, give you the quality that you need to reach the cloud, because you're going to manipulate your stream inside the cloud itself. And as everybody knows, you know, working with streams, when a stream enters one system, it goes out in a lower quality. So you need your first stream, when it enters the cloud, to be as best in the best quality as possible, because it will give you the better options at the end for the customer themselves. And there's, of course, the latency trade-off that you need to keep in mind, because when you use the FEC and encryption, you send your streams to different systems to do that for you. And the process itself will generate some kind of latency. So there's some kind of a trade-off when you do that between the latency and the security and the encryption.
Let me just throw in one other little note here, Ilan, and that's around security. This can't be understated. If you're, for example, and this is a little beyond television, but if you're a feature film producer and one copy of your release film escapes your security system, you can lose millions and millions of dollars. Less so in the theater era, but today in the over-the-top era, that thing appearing on the web in a rogue manner can literally cost millions and millions of dollars. So security is a very, very important thing as well for live production. I'll give a quick example. I'm sure everybody has seen in the news the stories about people holding Zoom meetings during the crisis here and having unintended visitors attend the meeting to disrupt. Hackers, basically. Yeah. The last thing you want on your live news show is me popping up with a tag ad. So security is a very, very big thing. We've never had to think of before, by the way. If you locked your equipment room, you were secure with SDI. Today, it's IP. If you have an internet hole, somebody's going to come in.
Yeah, everything is wide open on the network, and it can be intercepted by almost anyone. And if you don't use tokens and encryption, then anybody can be a pirate producer and rerun your event or your shows. Let's say sport events, which are very, very valuable because of the commercials in them. They can just privately broadcast them to their neighborhood or something like that. So you want to protect them.
You just need one file on the Pirate Bay or some other awful place, and all bets are off.
Yeah. We move on to the AWS as an example to talk about the regions, the EC2, the instances, cost, and some cloud services. The regions themselves, well, as probably people here know, all cloud providers will give you the possibility to deploy your VMs on different regions. The geographical distance means a lot when you talk about network and streaming. The closer you are to the stream, the better connectivity, better quality you get, and lower latency. So keep in mind the regions themselves, where you want to deploy the different systems of your live production. For example, I would deploy the monitoring solution near my NOC engineers, so they have better connectivity to those. And maybe the initial encoder on the cloud will be closer to the streams where they enter from the cameras or from the live events themselves. There are a few different families of instances that AWS offers and also other cloud providers. For the video live production, you probably want to use the compute optimized instances. They offer the strongest CPUs and high bandwidth network adapters, and also a nice amount of memory on them. There's, of course, there's the memory optimized and database optimized and a few other families, but talking video, when you talk about video, you probably consider the CPU optimized ones. Calculating costs, it's a big issue. You always want to know what's the bill going to look like at the end of the month. And if you don't do your calculations up ahead, you might find yourself with a really, really large bill. There's so many differences. Same VM will cost less in a different region. And of course, there's the difference between dedicated and shared VMs and bare metal VMs. All of that adds cost to your bill at the end of the month, things that you need to take into consideration. And every cloud provider today, almost everyone offers a calculator, a cost calculator. You can also, of course, consult with guys that providing the systems, like from the encoder guys, to ask which VMs are the best to use, or are the cheapest, or I don't know, the best for this use case, and so on. Network, of course, hard drives if you need them, other services. Multicast.
Ilan,
yes.
let me just jump in for a second, because it's an appropriate time to answer a question that came in. We've been asked, it seems the cost of moving data within the cloud is 5 times the outbound rate on AWS. Compression just trades I/O cost for compute cost. To be cost effective, it would seem you would want to stay within one server. What size production could be done in one large server? Well, Of course, that's an impossible question, because if you're doing it in SD black and white, you can get an awful lot more capacity than you can running 4K HDR. So it's a difficult question to answer, but there are some trade-offs to discuss. So for example, compression versus I/O cost. Is it really a direct trade-off? Is the compute power necessary to squeeze it down to the lower bandwidth to save money equivalent to the cost you're saving? So this touches on what has to be analyzed, but as Ilan points out, calculators are available from these people, and essentially what you need to do is take all your bit rates and assess them, add them up, look at the functionality you require, and then start assessing the cost of both the I/O for the bit rates you have, as well as the cost of services that would convert things and allow you to use a lower bit rate. It is a complicated problem. I wish I could answer the question, what size production could be done in one large server? It's impossible without a whole bunch of parameters. The other thing I'll mention, though, and Ilan, you can speak more to this, we're not limited to one server in the cloud. You can have compute instances and chain them together and use them all if you want for the same application. So you're not limited to one compute resource for a single application. Is that right?
Yeah, that's right. But also, I'll add on that you know, if you wanted to do that calculation on an on-prem environment, you would have to either loan or buy a server and try it, set it up, and all that. In the cloud, you can do a test run for a week, see your cost exactly, prepare, you know, play with the systems, get a better instance, get a you know, less strong instance. For your system, try it out and get, you know, fine-tune your topology to match your needs and to save money. So it's very flexible. You don't commit to it for life, like buying a physical server. So you took a few VMs, you tested it out, you pay, you know, your week's cost came around to, I don't know, $100, $200 spent, but now you have the education and the knowledge that you need to fine-tune your costs for the future, and you just got a you paid $200, but you saved in the future millions, probably.
Yeah, we didn't mention that, did we? You can always rent a piece of cloud and play with it. It's very cheap, as opposed to either a vendor demo or buying a piece of equipment to figure out what to do. And Ilan, I think that conversation about chaining together compute instances leads to your multicast bullet here.
Yeah, the multicast. Well, multicast is the unicorn in the cloud. It hasn't been approached for years, but lately Amazon AWS has offered the multicast capabilities on one region for now. In TAG, we tested the multicast capabilities. They are excellent and usable. Of course, we'll talk later on how they save you bandwidth and money and time and latency. But it is available. It just started, but I'm guessing in the in the near future we'll see it all over the regions and accessible by all the systems. Next up, Mezzanine Compression. Maybe actually, Paul, maybe you can shed a light a bit about the difference between J2K and JPEG XS.
Well, actually, let me instead talk about something a little different, and then I'll talk on those two. But mezzanine compression, just so we're all on the same page, is a lighter compression than distribution compression, the kind we use to watch TV. Mezzanine compression has a couple of attributes that are unique to it. One is a fairly low compression ratio, so it squeezes the bits but not very hard. The goal being to retain as much quality as possible. And when I say as much quality as possible, I mean quality that is used in a production process, not quality that's being used to drive human eyeballs, such as you'd send home to a set-top box. The reason this is important, you may be using those sources of picture for complicated visual things like chroma keying. And when you do, for example, chroma keying with crummy images, you get a really, really bad-looking chroma key. So in cases like that, or where you're doing multiple layers, you want to make sure you can maintain quality, although layering is less of a quality issue nowadays. So pretty much at the forefront of mezzanine compression in our industry anyway is JPEG 2K and JPEG XS. They both provide extremely high quality compression. They provide light compression, although the bit rate, the amount of compression is variable. So you can compress fairly heavily with them. JPEG 2K is well established right now for this purpose. But recently, JPEG XS has arrived, and JPEG XS exhibits extremely low latency, and this is very, very important for live, where J2K has a bit of latency that's worth considering. JPEG XS essentially has latency down at the engineering level and no latency to speak of at the production content level.
Oh, that's
So
amazing.
those two are the most important ones right now for getting to and from the cloud for live production content.
What's the average bit rates for these two protocols?
Probably your plus or minus a couple of hundred megabits, as
Mm,
opposed to 1.5 or 3 gigabits for the equivalent content
yeah,
in
of
baseband.
course. Yeah, but still, it's still reasonable when you're talking about live production, for professionals.
Right.
Next is the network monitoring and logging. Most of the cloud providers will give you that as an overlayer to your VM ecosystem. You can use that, for instance, for debugging aftermath drop-downs or major network events that happened, deep into the logs to see what happened. These are almost next to free tools that the cloud provider will give you, and we highly recommend using them just to have some idea of what's going in and out of your network and manipulate it and have control over it. And the stream probing and multiviewing, of course, any live production system configuration needs that. You need to see the streams, you need to know what's wrong with them, the proper problems that you had with your streams. Of course, any problems can translate to money at the end. So you need a good system doing that. Tag offers one of the best. And it's an essential part in any live production environment.
What do you mean one of the best?
The best.
Come on.
Tag is the best over IP multiviewing and probing solution. Yeah.
There you go. I just want to throw in one other little thing, because there is one advantage to cloud over on-premises when it comes to IP production systems. When you have an IP production system in your plant, you own your switch, you own your equipment, and you own every single aspect of your network, including troubleshooting and making it stable and work. Thus, you must provide the tools, the resources, the knowledge, and so on to do that. When you move to the cloud, you now have tools and resources available to you to keep the network happy. You don't have to manage your network the way you do with your own switch in plant, where every single thing touches that network and every single thing could potentially trip you. When you move a specific atomic production, for example, a production studio to the cloud, within that network, you're in an environment where you're not impacted by anything else on your own network. Your own IT people aren't going crazy wondering what the studio is doing, or vice versa. You have tools and resources available in the cloud that you don't have otherwise.
Yeah, I agree. I totally agree. Thank you, Paul. Let's talk about a bit about the different ways to move your stream around between your components in the cloud in the live production environment. Let's start with the UDP and TCP differences.
Yeah. Well, so TCP, let's start with that. I mean, TCP is what the World Wide Web's based on. TCP is transmission with acknowledgement, and TCP inherently means there's latency involved. And the reason for latency in TCP is that you have to have a receive buffer big enough such that if the transmitter sends the next packet and doesn't get an acknowledge, it will resend that packet, and it has to be stuck into the stream before that stream is decoded. So TCP involves two things: retransmission on packet loss. It involves latency as a result of the buffers necessary to do that, and you can still lose data. There's nothing that says that, you may retry 3 times on one single packet, it doesn't make it, the buffer's long gone, right? So TCP is not a thing for live production. In 2110, of course, we use UDP. UDP is brilliant, it's low latency, but UDP is a broadcast. UDP, you cast it to the wind and hope it arrives. And if your network's well managed, it will. If your network's poorly managed, it might. But the beauty of UDP is, unlike TCP, where if you are talking to 10 endpoints, you have 10 private transaction relationships going. With UDP, you broadcast it once, and however many endpoints want to receive that can receive it. So that's the difference, and that's why UDP is being used for low latency and being used for SMPTE 2110. The other equation relates to this, and that's multicast and unicast. Multicast, which is typically used with UDP, is the transport format that that allows UDP to be deployed and distributed across the network. Unicast describes TCP, so it's going from one point to another point only. And again, if your device is talking to 10,000, delivering a stream to 10,000 devices, it has to maintain 10,000 relationships and a transaction on every single packet on every single endpoint. So hence multicast is the common thing. Now,
Yeah.
multicast is coming in the cloud, as Ilan pointed out. As well, there are other services that are coming available in the cloud, which are not multicast, but offer a multicast-like transport. And this is how we can move between elements of code within the cloud, or to the prior question we discussed, even between compute instances. So I can't fit my studio into one compute instance. I do part of it there, and then I use multicast in the cloud, or I use a cloud provider's private method that's like multicast to get my stuff into the next compute instance and carry on processing. And you can chain processing nodes together as long as you want and build the biggest computer you can imagine.
But in general, when offer the multicast solution, go with that.
Absolutely.
Yeah.
Excuse me. Absolutely.
Mm.
Absolutely.
Thank you, Paul. The services, the main services that we're going to use in a live production environment in the cloud, the encoder, decoder, mezzanine, right, Paul? The reliability and secure way to transport your streams around, translating to offer different bit rates and different resolutions for different end customers, multiviewing, probing, monitoring, of course. Translating not only for the end customers, also for different systems in your network. Maybe you want to send the lower bit rate, lower resolution for probing to the probing system, because that's enough for you, and use the higher bit rates to move forward to the CDN and so on.
Sure. Or you're bringing in a Zoom meeting as a video feed for an interview, and it's at a lower resolution, and you have to upscale it to HD. I mean, this is common stuff.
Yeah. Production switcher, maybe you can say a few words about that.
The magic in the cloud. Production switcher in the cloud is the grail, of course. Everything plugs into the production switcher. The next bullet highlights a whole bunch of the things that you remember that initial block diagram.
Yeah.
That's the biggest piece of processing that's in the cloud, because that has to do a whole bunch of stuff. And in fact, compared to today's SDI vision mixers, there's a lot of complex compute going on there that's presently done in hardware. So it may take one, it may take more instances, but it's entirely doable in the cloud as well. I'll mention too, just a note here, some of these services, unlike today where we buy everything from a broadcast supplier, some of these services are cloud native, and the cloud vendor can actually provide many of these services as you glue together a system in the cloud. So things like reliable and secure transport, you don't have to necessarily buy someone's product. That may be a service you can drag and drop into your design in the cloud environment. Other pieces, such as the production switcher, playout, replay, slow-mo, they're very specialized, and those will still come from people who specialize in best-of-breed products, as TAG does with multi-viewing, probing, and monitoring.
Yeah. Thank you, Paul.
Sorry, one more thing though, go back.
Of course.
That last statement, all of it eventually can go to the cloud. Intercom, lighting control, the whole ball of wax. There's no reason why today we can't move everything into the cloud.
It's mostly software-based, so you can have a VM with Windows or Linux up, install the software, and then there you go. You have the CG infrastructure on the cloud itself.
That's it.
Yeah. Here's an example of a live broadcast environment on the cloud itself. So starting from the left, we have the studio feeds, the cameras that will send their feeds into either a cloud or on-prem encoder. The Zixi wrapper will securely move the stream to the cloud, open up the stream on the other end, on the cloud side. Of course, the multi-viewing and probing solution can should handle all of these packager outputs and the feedbacks from the CDNs. You're going to package your streams, use the DRM key server to encrypt your streams for security reasons, eventually send it out, of course, to another Zixi instance or any other forwarder or correction system, and to on-prem or to the NOC engineer's house. And of course, from the packages themselves, you'll probably be sending the feeds to the CDNs origins, to the origin CDNs to distribute between the edge servers and so on. So this is a good example of live broadcast working on the cloud and working well.
Really complicated. Boy, in the old days, it would have been encoder, transmitter, antenna, and that's the entire path.
Nah, today you want to have your content available in a fast and secure way to all the customers around the world. The world became this small. You know, everybody wants the content from anywhere. So, and it's possible to do that. You can have CDNs spread out, edge servers spread out throughout all the continents.
That's a whole topic for another day.
But
So
this
just
one looks like the earlier slide
kind of
that you
does,
showed.
doesn't it?
Yeah, what's the
Yeah.
difference?
So can anybody spot the change in the drawing? If you go down the very bottom, there's a little red oval around the network. It used to say network. Now it says cloud. Nothing really changes. The formats and the encodings of some of these lines connecting things together will change necessarily as you move to the cloud as opposed to a switch that's in the back room. But the functionalities and how they're connected in terms of flow doesn't change. So when we move live production to the cloud, there certainly are social changes. You no longer have a control room full of people. The character generator operator is sitting in their underwear at home, perhaps. The vision mixer, he's sitting somewhere, the technical director. These people are in a different environment, but what they do, the equipment they use and how their systems work doesn't have to change, but it can. And that's the beauty. We can evolve into the cloud doing all the same things we do today. We can just take, for example, the vision mixer into the cloud, leave the rest of its stuff on-prem. All we need is the bandwidth between them to connect these two networks, right? Yeah. So you can do an evolutionary hybrid approach, or you can build the whole thing clean in the cloud. It's entirely up to you. And that's the beauty of cloud and IP. But what we can do today that's most important is we can do the very same thing tomorrow in the cloud we do today in our buildings, but we can then evolve these production systems flexibly. Right now you build a studio, it's wired. To evolve it means downtime and a whole bunch of complexity, capital expenditure, and so on. When you have a studio in the cloud and you want to evolve a production idea, you can try it out. It costs you per hour. It costs you some software.
Yeah.
It's a whole different world where we can now evolve much more rapidly into new ways of working. Yeah. But this was important to show because nothing has to change. That's up to you. So going forward, the cloud will enable us to do more creative things.
Yeah, of course. Thank you, Paul.
And there's huge advantages. You want me to talk to this?
Yeah, please. Go ahead.
Sure. Well, what are the cloud advantages? Well, cost. You rent them as you need them. So if you have a 1-hour news show per day, you pay for 1 hour and 30 minutes of studio time in the cloud every day, as opposed to a studio where you turn off the lights for 22 hours and 30 minutes a day. We have redundancy available in the cloud. You don't have to build duplicate systems. The cloud can do that for you. You can even use 2 different cloud providers. If you don't trust them, I wouldn't. I'd put one on Amazon, I'd put one on Google. And if one path goes down, I'm covered. If one goes bankrupt, I'm still on the air. Scalability is really important. Maybe today you need 2 cameras, maybe tomorrow you need 40 cameras. Dial up what you need on the day of demand. This is on-the-fly capacity adjustment. You can do what you need to do on an ongoing basis and always optimize your cost. We have fault tolerance in the cloud through load balancing, the CDN, multiple providers. There's lots of ways to build resiliency into the cloud, and it's high availability. Probably better than your own TV plant, unbelievably, but it's equal at least to what we're used to. This flexibility for pop-up events is part of the flexibility equation. If something comes, there's a news event, you can stand up an event channel very quickly, as opposed to repurposing a room in your building and trying to figure that out.
Not only that, you can also scale your systems up if you need. If you have, you need more encoders, in a click.
Yeah.
You do that.
Sure. You want to bring in 10 more cameras, you want to bring in 5 more remotes, absolutely. Click and you're done. Yeah. There's not people running around patching and so on. It's geographically insensitive. Your character generator operator can be in their underwear today in North America, and they could be in their underwear tomorrow in Europe doing the character gen. You don't have to care. This system reaches globally. That's the beauty of the cloud. You now have flexible staffing opportunities and potentially reduced staffing. You don't need IT guys if everything's in the cloud. That IT support's in the cloud. Just one example, but you can now more flexibly use your staff. You don't have to move them physically from location to location and have travel time in between. They can do 3 shows a day in 3 different countries. Collaboration's easy. This is the internet. Let's move to the place where the rest of the world collaborates, right? We can reduce the gear at the venue. We don't need a huge production truck. We need remote control cameras and nothing much more, and lots of production is being done that way right now. Of note today is there's no control room necessarily. And I note coronavirus, simply because they can't work in a control room today. But remote production, of course, enables them to keep making television. And one real key point is use of internet streams. And this is what we see on the talk shows, contributions coming from Zoom and things like that. Hard to do in a legacy plant. You have to have a decoder and a receiver and a whole bunch of stuff and a PC. Of course, internet streams are native. We can bring them in and use them natively in our environments. So there's huge advantages to looking at the cloud for live production.
Thank you, Paul. I guess we reached the end. If are there any questions people want to ask? Maybe we can attend to them.
Yeah. Let me have a look on the question machine here.
Yeah, me too.
And see what's come through. Ah, I got a question.
Oh, got a few.
Hang on here. Would you agree with the following? By utilizing a UDP transmission methodology, there will be a greater emphasis for 2110-21 traffic shaping. Well, okay, so traffic shaping in 2110 today is a very necessary thing. The reason is because our streams are still pushing the limits of interfaces. If you have a 10 gig interface, you can't fit a 4K P60 or P50 picture in that. So we have still physical limitations. We're able to do it, but it's still not as just easy as plugging in the wall kind of thing. So the 2110-21 traffic profile is immensely important for interoperability at this time. Within the cloud, that's a different story now, because using multicast in the cloud, yes, if we were going between instances with 2110, we would follow the 21 timing model for video, certainly, because it's multicast. If, however, we were using a proprietary equivalent data transfer, say, provided by one of the cloud providers, where they offered a low latency data path like multicast, but it really wasn't multicast, we then can look at freeing ourselves from the timing model. I'm also personally of the opinion it's time to revisit the timing model and add a couple of modes, because going forward, the timing model, if I can back up, it's no different than analog video. The pixels come from top left to bottom right, scanning along the screen. And that's great, it's evolutionary, it fits beautifully, but we live in an era now where if I have my pixels in my hand, I should be able to transfer them in a microsecond or a millisecond to the next stage of processing. I shouldn't have to wait an entire frame, and that's what 2110 does right now, is it makes you wait. So it's important, and it will become even more so important as we look to improve efficiencies of network transfer for live media. Hope that touched on an answer.
Yeah, I got a question here as well. Is the tag multi-viewer architecture capable of handling both uncompressed and compressed input feeds, or must it totally singular? Well,
you got the easy question.
Yeah,
you got the easy one.
Well, you thought you got the age benefit. So leave me with this easier questions. Yes, of course, we can do uncompressed, compressed, most types of OTT, like HLS, of course, MSS, and Dash, 2110. We can do J2K, of course, and our output is also HLS, NTS, and uncompressed. Please be in touch with our sales guys that will give you all the knowledge you need. See anything else interesting there, Paul?
Is there a common or standard interface between cloud processing components? How does the tag multiviewer interoperate with other processing blocks? So right now, our interoperation with other blocks is through multicast, and multicast is available now, at least in one region for test. And we've tested with that, and it works just fine. So right now, multicast is it. Our goal is ultimately that we will support any inter-element protocols that any cloud provider provides, because all we want to be able to do is glue stuff together in the cloud, and if a vendor has a way to do it, we can adopt that, and then it's your choice what you use.
Well, basically, I can also add on that we talk network. As long as you give us access to the stream and have access to our output, then you're covered. We can talk with anybody, almost anybody in any protocol, any known protocol. Just give us access to it and have access to the output. It's that easy. We didn't find any points in which we failed to connect with other systems like encoders or decoders on the cloud or on-prem, of course. I think this is all the questions we had.
That's it.
Yeah.
Well, thank everybody for attending. I'll throw it
Yes,
back
thank
to
you.
Ilan to wrap up the ribbons, but I appreciate your time.
Yes.
Feel free to contact us. He's Ilan and I'm Paul, and if you want to contact Tag and ping us, please, by all means, we'd be happy to talk to you and answer any further questions you have. Over to you, Ilan.
It's okay. I think you wrapped it up quite nicely. Thank you guys for participating. We have many more webinars coming up. Join them as well if you want to, and check out our site. You'll find a lot of knowledge there and some points on our systems and solutions on the cloud also. And feel free to contact us anytime. Thank you, guys.
And everyone stay safe and stay healthy, and we'll be talking again soon. Thank you. We appreciate you attending.
Thank you very much.